So so the next concept is shift registers. So in the previous video we had a discussion regarding registers which are made up of flip-flops, right? So as we all know, like register might be 3-bit, 4-bit or 8-bit, something like that, okay, depending upon the number of flip-flops present within a register. If we have 4 flip-flops, it will be a 4-bit register. If we have 3 flip-flops, it will be a 3-bit registers. If we have 8 flip-flops, obviously it will be called as 8-bit registers, okay. So as I just told, we have 4 types of shift registers. One is serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. So what are these serial in, serial out, serial in, parallel, parallel in, parallel out, and parallel in, serial out? So let me go one by one, okay. So these are the types of shift register where we are going to shift the data in serial in and serial out, or something like that, okay. So let me show. A shift register is a register in which binary data can be stored, and this data can be shifted towards the left or right when the shift signal is applied. So there is a shift signal. Whenever the shift signal is applied, the data which is present in first flip-flop will be shifted towards the second flip-flop, and the data present in the second shift flip-flop will be shifted towards the third flip-flop, and the data present in third flip-flop will be shifted towards the fourth, and the data which is present in the fourth flip-flop will be sent to the output. This is how the shifting towards the right, or we can shift it towards the left, backward side. So this is what we call shift registers, okay. So look at this diagram, okay. So whether it is a 4-bit shift register or 3-bit or 8-bit shift register, how many flip-flops we have? So we have 4 flip-flops, 1, 2, 3, 4, okay. All the flip-flops are D, because D3, D2, D1, D0. So D flip-flops means single input, single output. So look at here, this is serial in. The data is entering from this side, and this is serial. The data is getting outside, SO and S in. Once the data enter from this ear, it will be sent out here. So before sending out, it will be shifted from ear to ear, ear to ear, and ear to ear. This is what shifting towards the right, okay. So let me assume we have a clock pulse. This is a positive edge trigger because we don't have a bubble with respect to the clock pulse. So the system changes its state, changes its state in the sense of shifting the data, changes its state only during the positive edge trigger because we don't have the bubble over here. So then look at this. What is CE? CE refers to class enabled. So before we called it as a gate, load, something. Here we call it as shift. If the shift is 1, obviously the operations will be performed. If the shift is 0, none of the operations will be performed, okay. So right now let me assume, so we have 0, 1, 0, 1. So this flip-flop containing 0, this flip-flop containing 1, this flip-flop containing 0, this flip-flop containing 1, okay. So now I am going to pass 1, serial input containing 1. So before this data enter this flip-flop, so these flip-flops already containing 0, 1, 0, 1, okay. Right now at present this flip-flop containing 0, 1, 0, 1, okay. So when the clock pulse is applied, when the shift is 1, this 1 will be sent here, this 0 will be sent here, this 1 will be sent here, this 0 will be sent here, and this 1 will be output, shifting towards the right, okay. So you can look at the connections from ear to ear, ear to ear, ear to ear. Simple. Shift right, shifting the operation towards the left. Shift left means going in this way towards the left, that is shifting left. So they are given the waveform here. So let me explain here. So right now we have 1, 0, 1, 0, 4 flip-flop. Flip-flop 1 containing 1, flip-flop 2 containing 0, flip-flop 3 containing 1, flip-flop 4 containing 1, okay. So next the serial input will be 0. If I want to pass 0 to the flip-flop, so this 0 will be passed here, this 1 will be shifted to the second position. We have 0 in the second position, that will be shifted to the third flip-flop. We have 1 in the third flip-flop, that will be shifted to fourth flip-flop. We have 1 in the fourth flip-flop, that will be sent to the output. So next again we will send 1 in the serial input, so that will be sent to the first flip-flop. First flip-flop containing 0, that will be sent to the second, and second flip-flop containing 1, that will be sent to the third. Third flip-flop containing 0, that will be sent to the fourth. So right like this. At the starting it was 1, 0, 1, 1. Now it is 1, 0, 1, 0 after 2 shift operations, okay. The same way they have explained here. This complete operation will be performed only during the positive edge trigger, okay. Positive edge trigger means you need to concentrate on this, not on this positive edge trigger, okay. We call it as a positive edge trigger. So look at this. When the clock moves from 0 to high, what is serial input? Serial input is 1 because it is high, right? Serial input is 1. Okay, so this 1 will be passed to the Q3. This 1 will be passed. Look at the arrow mark. This 1 will be passed to Q3. So when it is positive edge, what is Q3 containing? It is containing 0. This 0 will be passed to Q2, second flip flop. So when it is positive edge, Q1 containing, so Q2 containing 1, that 1 will be passed to Q1. So Q1 containing 0, this will be 0, will be passed to here. So here it is 1, this will be passed to here. Here it is 1, that is going to pass here. Here it is 0, that is going to be passed here. Here it is 1, that is passing here. Like this, it will be shifting towards the right. This is what we call as shift right. And this is the data is passing serially in and serial out. This is serial in, serial out, shift register. Okay, remember it is a serial in, serial out, shift register. Okay, this flip flop is made up of D flip flops. In your examination, they might ask you to write 4-bit serial in, serial out, shift register using D flip flop or JK flip flop or SR flip flop or T flip flop. You need to write by using the respective flip flops. Okay, let me go. The same explanations they are given. There is nothing much difference. Whatever I'm just explaining, the same thing they have explained here. You go through this data. Okay, explanation. So look at this. How many flip flops we have? 1, 2, 3, 4, 5, 6, 7, 8. So how many bit registers then it is? This is a 8-bit shift registers because we are having 8 flip flops here. So look at here. This is serial in, serial out, 8-bit serial in, serial out, shift registers. Okay. So we have constructed this register by using SR flip flop, 2 inputs. So in case of D flip flop, we had only a single input. So SR flip flop, no, we have 2 inputs, S and R, S and R, S and R, S and R. So like this. So all of them are connected by a clock. All the clock is positive triggered, and we have a serial input. So in the previous, we had directly connected to D3 because we had a single input for the flip flop. D flip flop containing single input, single output, right? But SR flip flop contains 2 inputs, S and R. So one is connected directly S, other is connected to a NOT gate via R. Hope you remember, S refers to set, R refers to reset, S and R. So let me assume right now we have 1, 0, this is 1, this is 0, 1, 1, 1, 0, 1, 1, something like that. Okay. So now I'm going to pass 0 here. If S is 0, it will be converted to 1 here. 0 and 1. S is 0, R is 1 means reset. Reset means the flip flop should be set to 0. This 1, the previous state 1 is there, no? That will set to 0. The one which was present previously, that will be transmitted to the next flip flop. S1, R0. So if this becomes 0, Q becomes 0 means Q bar becomes, so this one, let me tell you, wait. Right now we have 1 0. Okay, I am just passing 0 here now. So when I pass 0, S is 0, R is 1. S is 0, R is 1 means remember the truth table of SR flip flop. So when R is 1, S is 0, that's a reset state. So it is going to reset this 1 to 0. So this 1 which was present previously, that will be transmitted to this flip flop. Now this 0 will be converted to 0. And this 0 will be shifted to here. This 1 will be changed to 0. This 1 will be shifted to here. And this one will be shifted to here, this one will be shifted to here, this 0 will be shifted to here, this one will be shifted to here, and this one will be shifted to here. Okay, so if this 0 wants to come here means by passing all these 8 flip flops, it has to undergo 7 cycles because it has to shift 7 times from here to here, here to here, here to here. So in order to make this data to be passed to the output, it has to undergo 7 clock cycles. 1 clock cycles, it will be shifted to here. Second, it will be shifted to here. Third, it will be shifted like this. So for every clock cycle, it will be shifted to one flip flop, one portion towards right. So if you want to send this 0 to the output, then it has to undergo 7 clock cycles. Look at this waveform. So this is serial input, this is serial output. So right now it is 1. This one, if you want to see this one to the output, means it has to undergo 7 clock cycles. So first it will be shifted to here, next year, next year, next year, next year, next year, next year. After that it will come to the output. If you want this high to output more, means it has to undergo 7 clock periods. Look at here, this is 1. If you want to see this one to the output, this has to see 7 clock periods. Great. So this is serial in, serial out shift registers, 8-bit serial in, serial out shift register, which was constructed by using SF flip-flop. Okay, serial in, serial out. Okay, the same explanations they are given here. So let me go with a parallel in, parallel out shift register now.